The old internet was a static library, a place we went to passively read information. But today, the new internet is an automated factory, executing decisions and managing capital autonomously while we sleep. But looking at how modern finance actually operates, it is still dragging along human bottlenecks. Every manual approval, every dashboard click, and every compliance check creates latency. In financial systems, the delay between a decision and its settlement is pure economic leakage. Early blockchain networks tried to fix this by enabling instant, permissionless settlement. They solved the speed problem, but they walked right into what we call the transparency trap. Traditional public ledgers expose everything. Every wallet balance, every trade history, and every execution strategy is broadcasted to the world. For an institutional trading desk or a corporate treasury, that public exposure is an absolute liability. For serious capital to flow through these networks, this system requires the execution speed of crypto, but with complete, bulletproof confidentiality. This brings us to the machine economy. We are moving past the phase of chatbots giving us financial advice. Instead, we are now deploying fully autonomous AI agents that actually control and deploy treasury funds in real time. Delegating capital authority to an autonomous model creates an operational paradox. You must verify that the machine is acting safely, but traditional methods of auditing require exposing the AI's proprietary logic and trading strategies. As the cost to automate cognitive tasks drops exponentially, it crosses below our human capacity for manual oversight. This crossing point is the measurability gap. Here, a single logic error scales instantly, cascading as a cadential drain before a monitor can even react. Surviving the machine economy means we can no longer rely on human oversight. The machines have to audit each other, and they have to prove their reliability to the outside world without leaking their underlying code. To build that self-auditing structure, developers use frameworks like the Paperclip AI Orchestrator. It acts as a decentralized control plane, managing entire organizations of autonomous agents. The first rule of this architecture is that single-agent systems are too dangerous. As shown on this dashboard, the orchestrator replaces the lone wolf AI model with a rigid corporate hierarchy, ranging from a CEO down to specific governance rules. The workload is strictly compartmentalized. The CEO agent focuses entirely on global strategy and delegating tasks, while the quant agent monitors live token spreads and calculates the risks of instant arbitrage routes. Before capital moves, independent quality assurance agents audit these commands at intermediate checkpoints. By introducing this secondary layer of verification, the system breaks the cycle of unverified logic and prevents a single agent's error from compounding into a system failure. This level of automated coordination directly replaces legacy SaaS tools and expensive human consultants. Deploying these continuous automated smart contract audits eliminates up to $50,000 in manual security overhead per run. Internal system stability is only achieved when agents independently verify one another. That check and balance system prevents the measurable gap from causing ruin. So the swarm trusts itself internally. The next hurdle is interacting with the outside world. How does an autonomous treasury prove to an external smart contract that it is solvent and safe to interact with? The solution relies on autonomous identity profiles. These act as on-chain passports that log an agent's historical performance, success rates, and execution reliability, entirely independent of a real-world identity. To communicate this trust, the system uses zero-knowledge proofs. Think of it like this opaque locked box. The private data stays hidden inside, but the box mathematically emits a verified signal, the glowing checkmark, proving that the contents meet strict compliance standards without ever actually opening the lid. An agent can approach a liquidity pool on Algorand or the XRP Ledger and submit this mathematical proof. It confirms to the counterparty that the agent has a 95% task completion rate and holds the required collateral, all while keeping the actual wallet balances totally obscured. In a mature machine economy, exposing raw data is a critical vulnerability. Mathematical proof becomes the only secure dialect for automated commerce. All logic settles inside a cryptographic core, the vault. At the center, the TEE Guardian Shield represents hardware-level secure enclaves, housing multi-chain machine logic. The trusted execution environment actively isolates memory, verifying its own integrity and locking out unauthorized interference during the transaction. This removes the layer of manual dashboards and human approval clicks, replacing the user interface with programmable intent, where the hardware itself enforces the execution rules. We reach a point where complete operational privacy and absolute mathematical proof can exist at the exact same time. The zero-human enterprise operates as a verifiable, self-healing network. Trust is not assumed through a brand name. It is cryptographically proven in every single transaction.